IFR training videos by
Toga Thrust.
ILS approach. Agenda. Introduction. System description. Approach chart description. Approach follow-up. Failures and contingencies.
Introduction.
We are facing major changes in aviation, mainly in instrument flying. With the growing importance of satellite positioning, old-fashioned navigation and approach techniques will soon become obsolete. What about pilot core competencies? Are we bound to follow the line and nothing more, or should we keep training those procedures and techniques to keep what makes a pilot, mastering? You think right if you are watching this video. Let's train as a pilot. Satellite navigation and approach techniques will be a part of your training.
Theory.
System description. The localizer and glide path beams being very narrow and sensitive to disturbances, their interception must always be validated using another navigation source. For the localizer, this can be done using AVOR, ADF or RNAV. To validate the glide path, we used one or two markers, very punctual vertical emission beacon, more and more often replaced by a DME, distance measuring equipment, whose advantage is to provide continuous distance information. The DME is most often co-located with the glide path, thus directly giving the distance to the runway threshold, which is very practical. An indicator light and an audible signal are activated when each marker passes. The DME distance information is provided on the DME display. From a practical point of view, the user displays a single frequency, that of the locator, included in the VHF range 108.0 to 111.95 MHz. The glide path and DME frequencies where present are in different frequency ranges, UHF, but match to that of the localizer, so this remains transparent for the user. The certified range is 15 to 20 nautical miles for the localizer, 30 to 50 nautical miles in practice, slightly less for the glide path. The DME of an ILS, less powerful than a DME en route, can nevertheless be received up to 50 or even 100 nautical miles.
Advantages of ILS.
Very high precision. Under certain conditions, clearance of critical areas, increased separations between aircraft, electrical emergency, specific marking, etc., it is possible to carry out automatic landings and therefore to land with very low visibility.
Disadvantages of ILS.
Sensitive to disturbances in electrical harnesses, by vehicle or plane on the ground or plane in flight. Occasional existence of false axes by reflection of the beam on a relief. Narrow beams requiring assistance for capture.
The localizer
is made up of a set of antennas located after the end of the runway which emit a VHF carrier between 108 and 112 MHz, first odd decimal place, 111.75 MHz for runway 26 at Orly, for example. It is modulated by two low frequencies, one at 90 Hz and the other at 150 Hz. To the right of the track axis, the modulation rate of 150 Hz is greater than that of 90 Hz and conversely to the left of the axis. The difference in rate makes it possible to deduce a difference which is displayed on the onboard receiver. There is added modulation at 1020 Hz which transmits the station identification Morse code generally corresponding to 2 or 3 letters of the alphabet, Oscar, Lima, Whiskey for runway 26 at Orly, for example, transmitted at least 6 times per minute. The radiation pattern is open by approximately 35 degrees in the horizontal plane and 7 degrees in the vertical plane. It should be noted that the linear guide zone only covers a maximum opening of plus or minus 5 degrees around the axis position. This system is sensitive to multipaths, reflections, diffractions, etc. To reduce the phenomenon, most ILS are dual frequency, two very close VHF frequencies. a VHF frequency for guidance in the runway axis, called directive, and a frequency for coverage in the horizontal plane, called clearance. The onboard receiver captures the strongest signal.
The glide path
Consists of a set of antennas located 120 meters to the side of the runway, near the threshold, which emit a UHF carrier between 328.65 and 335.40 MHz matched to the localizer frequency. It is modulated by two low frequencies, one at 90 Hz and the other at 150 Hz. Below the glide plane, the modulation rate of 150 Hz is higher than that of 90 Hz and vice versa above the plane. The difference in rate makes it possible to deduce a difference which is displayed on the onboard receiver. They provide an adjustable descent plane, generally of the order of 3 degrees, between 2.5 and 3.5. The radiation pattern is opened by approximately 16 degrees in the horizontal plane and 7 degrees in the vertical plane. The glide beam is no longer usable from 15 meters, 50 feet. For automatic landings, the aircraft is guided by information from the radio sound and the variometer. The markers are vertical emission radio beacons, NDB or non-directional beacon, placed on the final trajectory of aircraft transmitting at 75 MHz. They are gradually being replaced by DMEs matched to the frequency of the localizer. The outer marker located approximately 8 km from the threshold is modulated at 400 Hz. It lights a blue light in the cockpit and emits a Morse tone of 2 lines per second. The middle marker located approximately 1 km from the threshold is modulated at 1300 Hz. It lights an orange light in the cockpit and emits a Morse tone of 1 and 1 dot per second. The inner marker located approximately 100 meters from the threshold is modulated at 3000 Hz. It illuminates a white light in the cockpit and emits a Morse tone of 1 points per second. Special categories of ILS approach are defined, which allow suitably qualified pilots, flying suitably equipped aircraft, to suitably equip runways, using appropriately qualified ILS systems to continue an ILS approach, without acquiring visual reference to a lower DH than the Category 1 standard of 200 feet above runway threshold elevation, ARTE, and do so when a lower reported RVR than the 550 meters usually associated with Category 1. Category 1 permits a DH of not lower than 200 feet and an RVR not less than 550 meters. Category 2 permits a DH of not lower than 100 feet and an RVR not less than 300 meters. Category 3A permits a DH not below 50 feet and an RVR not below 200 meters. Category 3B permits a DH of 0 feet and an RVR not less than 75 meters. Category 3C is a full autoland with rollout guidance along the runway centerline and no DH or RVR limitations apply. This category is not currently available routinely primarily because of problems which arise with ground maneuvering after landing. To be able to perform other than Category 1 ILS, the pilot must be qualified. Aircraft must be approved. Airport must be approved and low visibility with Category 2 or Category 3 ILS must be in force, for critical area protection.
ILS approach chart description.
The way to get started is to quit talking and begin doing. Walt Disney.
To have the complete description of the Jeppesen approach chart, please refer to the presentation. Approach chart description. ILS approach follow-up. Step by step.
We will depict all the approach phases step by step. Of course, if ATC guides you with radar vectors, then only the final phase, inbound to the final approach fix, established on the localizer, applies. There are three ways to arrive at the initial approach fix. The routing of the initial approach will depend on the sector you are coming from. 1. Arriving from a sector 30 degrees maximum each side of the outbound reverse track. 2. From outside that 60 degrees cone, either with an entry in the holding pattern, or 3. Directly on the positioning turn westbound. Let's have a look at those three possibilities. Note: an entry in the holding pattern is always possible if you're not ready for the approach, with the proper clearance from the ATC of course. (1) Arriving from a sector 30 degrees maximum each side of the procedure turn outbound reverse track. Where's the procedure turn outbound track? Where is the outbound reverse track then? What is the 60 degrees cone, 30 degrees each side? What can we do if our arrival route to the IF is within that cone? Yes, you can, after advising ATC, proceed directly to the outbound leg of the procedure turn. (2) From outside that 60 degrees cone. Except with a clearance from the ATC, you are not supposed to proceed directly on the outbound track of the procedure turn. Coming from this direction, what should you do? Proceed to the initial approach fix. Enter the holding pattern, refer to the training video for holding. Then, perform the positioning turn as depicted, CAT at 278 degrees 1 minute half, and come back to the IF according the procedure, note 2:074 degrees for CAT A. Now, proceed on the outbound leg of the procedure turn. 3. Arriving from a sector 30 degrees maximum each side of the positioning turn outbound reverse track. Where is the outbound track of the positioning turn? Where is its reverse track? Where is the 60 degrees cone? If we are within the cone, we do not have to enter the holding pattern to position ourselves, we can proceed directly for the outbound leg of the positioning turn, note 1:278 degrees, 1.5 minute. Then come back to the IF according the procedure, note 2:074 degrees for CAT A. Now, proceed on the outbound leg of the procedure turn. Until now, our minimum altitude is 3,000 feet. No descent is allowed until established on the localizer and passing the final approach fix, glide slope interception. Minimum altitude in the holding pattern is 3,000 feet. Minimum altitude in the outbound leg of the positioning turn is 3,000 feet. Minimum altitude passing the initial approach fix outbound is 3,000 feet. Minimum altitude during the inbound turn is 3,000 feet. Minimum altitude inbound to the final approach fix is 3,000 feet. Final approach fix is indicated by this icon. From the point, radial 074 degrees, DME 10.5 we can start the inbound turn to the left, or if cleared to an intercept heading if we are on radar vectoring. Of course, depending on our ground speed, we will surely have to stop our turn before reaching the front course 244 degrees, otherwise we might find ourselves flying parallel to the localizer. As the goal is to intercept the localizer, the best is to stop the turn at 30 degrees interception heading, here, heading 274 degrees.
Next will be lock alive. Lock alive, next will be on the lock. On the lock, next will be glide alive. Glide alive, next will be glide 1 dot. From this point, the procedure described will be based on Diamond DA42G1000 procedures. You can adapt it to the actual aircraft you are flying, if needed.
At glide slope 1. Before capture, select the flaps approach.
Next will be on the glide.
On the glide slope, perform the 5Gs acronym. Gear, down. Glide, slope follow. Go timer, if needed. Go around, altitude set. Green lights, check gear and flaps lights.
Next will be outer marker check.
Outer marker 1,800 feet, check with altimeter indication to check the altimeter accuracy.
Next will be 1000 AGL.
At 1,000 feet above ground level, AGL, we apply the approach ban philosophy. The approach ban, NCOOP.210, prohibits the continuation of an instrument approach below 1,000 feet, when the reported RVR is below the operator's aerodrome operating minimum. It is intended to avoid an unacceptable rate of go-arounds when visual reference cannot be acquired and maintained at DH, MDH. To make it simple, an approach can always be started, whatever the weather conditions. At 1,000 feet AGL, you must have the minimum requirements to shoot the approach. Here, RVR of at least 550 meters for a full ILS, 3D, 1,200 meters and ceiling at 404 feet for a lock, glide slope out, approach, 2D. So, at 1,000 feet AGL, grab the mic and just say, RVR check and get the actual data. If above the minimums, then continue, if not, then go around. After passing the 1,000 feet AGL where you had the required minimas, if they drop below the minimum required, you may continue the approach.
Next will be 500 above minimas.
Here, we have to make a distinction between MDA, H, and DA, H. DA, H, decision altitude, height, it's the altitude or height at which you make the decision either to continue for landing, or go around. Of course it takes a little time during which the aircraft continues the descent. In a go-around at the DA, H, you will continue to descend slightly below the DA, H, during the procedure. This is allowed because it is a decision altitude, height. MDA, H, minimum descent altitude, height, you are not allowed to descend below that altitude, height, decision must be made before reaching that altitude, height, so you do not go below that floor. That is the reason why, on some airlines, they add some feet to the MDA, H, for the decision-making time, 50 feet, 30 feet, 0 feet. Adding some feet to the MDA, H, is the decision of the operator only, airline or you if you are flying as private, and here, he can also consider the minimas as a DA, H. Once a go-around is started, it cannot be stopped. For a full ILS, we are talking about a DA, H, as it is a 3D approach. For a lock, glide slope out, approach, a 2D approach, we will use the MDA, H, but you see in Note 2 that the operator may decide to use it as a DA, H, if it is flown on VNAV. At 500 feet above minimas, here, 1,276 feet QNH, we check that we are stabilized on the approach. Checklist done.
Next will be 100 above minimas.
At 100 feet above minimas, we start looking outside, but just a short look to assess if we see the runway or lights for guidance. For that, before looking up, we release slightly the pressure on the yoke, as the head movement will surely be accompanied by an uncommanded pull on the stick, and you will leave the glide for sure. If no visual clues for landing, come back to instruments, and look outside from time to time to search for visual guidance.
Mínimas.
If visual clues are found, announce
Visual, continue.
and proceed for landing. Follow the visual guidance if any, Poppy, Vassie, and land. If no visual clue is found, then, at mínimas, call
Go round.
and proceed for the depicted procedure, except if you have received another clearance by the ATC.
Go round.
The go-around will be flown exactly as depicted on the approach chart. Climb straight ahead on radial 244, max 185 knots. At DME 6.0 Gosly, turn right inbound to Vor climbing to 3,000 feet. Main things to remember when you are preparing the approach and do the briefing: refer to the briefing presentation, are first, and maybe second, direction and first, and maybe second, altitude. For example, if the go-around procedure says, continue straight ahead until 500 feet AMSL, then turn right heading 354 degrees and climb to 4,000 feet AMSL. Then remember straight ahead, 500, 354 degrees, 4,000. Altimeter bugs will be set to 4,000 feet, which is the go-around altitude without level off. If there is a level off during the depicted procedure, altimeter bugs will be set to the first level off depicted to avoid any altitude bust.
Go round.
At this point, you have the choice to either restart the approach procedure, enter the holding to assess the situation and make a decision, or depart to your alternate.
Failures, irregularities and contingencies.
As a good pilot, you know that things are not always working as expected. So you are ready for as much as unexpected events as possible. Among those, what can you foresee? No talking about airport closure or aircraft technical defects such as engine failure or hydraulic failure, but only considering weather and/or navigation instruments.
Weather.
In this case, full ILS. It's simple as it is the most precise approach type and the one allowing you the lowest visibility and ceiling, typically 550 meters RVR and 200 feet ceiling. If the weather falls below those minimum values, your only option is to discontinue the approach and either proceed to enter a holding if you have fuel enough to wait for better weather conditions, or to go to an alternate with more friendly weather forecasts. Of course, as a good pilot, you already plan that, if you were to decide to divert, you would go to such airport that has such conditions according the destination alternate rules.
Instruments.
What can go wrong with my indications? Airport side. Failure of the antennas, system. Distortion of the beam due to vehicle inside the protected zone. False beam, ghost beam. Aircraft side. Failure of the instrument. Failure of the glide path receiver. Failure of the localizer receiver. Failure of the screen, AFIS.
Failure of the antennas system.
In that case, you don't receive any information from the system. ILS is inoperative, do not start the approach, or go around. Ask ATC.
Distortion of the beam due to vehicle inside the protected zone.
Make the difference between holding position sign and ILS critical area sign. A vehicle passing the ILS critical area line when low visibility approaches are in progress might provoke a beam distortion and a false indication on your instruments. A deflection of more than half-scale lock or glide requires a go-around.
False beam, ghost beam.
A characteristic of the glide slope portion of the ILS, instrument landing system, in which one or more false glide slopes at different angles to the horizontal occur well above the true glide slope. This is because of a radiation pattern of the antenna and the ground reflection of some of the transmitted energy, resulting in more than one overlapping lobe. The false glide slopes occur at odd multiples of the true glide slope angle, typically 3 degrees, i.e., at 9 degrees and 15 degrees. At even multiples, 6 degrees, 12 degrees, a centered glide slope needle occurs, but this is because of a null signal. Reverse sensing is present above and below these glide slopes. A pilot can easily recognize this false indication by the steeper than normal rate of descent. Pilots will not experience false glide slopes below the true glide slope angle. Pilots can avoid encountering a false glide slope by following published approach procedure. This is one of the reasons why you have an outer marker altitude check during the ILS procedure, or an ILS versus DME check. It is to make sure you are on the correct descent slope. The other reason is to make an altimeter accuracy check.
Failure of the instrument.
You have no more indications on your PFD about your ILS positioning. Above 1000 feet AGL, you can reconfigure to another type of approach, reset your minimas, brief the approach differences and the descent profile. If you completed all your tasks before 1000 feet AGL, then you can continue the new approach. If not, go around.
Do not forget that, now, you need new RVR minimas and ceiling, for 2D, to be authorized to start the approach.
Below 1000 feet AGL, go around and prepare for another type of approach. No real need to consider a diversion as the problem is coming from your equipment. Of course, if ILS is the only approach available, you have to change approach, or divert to another airport where you can use a different approach type.
Failure of the glide slope receiver.
You have no more indications on your PFD about your ILS vertical profile positioning, glide path. Above 1000 feet AGL, you can reconfigure to lock, glide slope out, approach, reset your minimas, 980 feet, brief the approach differences and the descent profile. If you completed all your tasks before 1000 feet AGL, then you can continue the new approach. If not, go around.
Do not forget that, now, you need 1,200 meters RVR to be authorized to start the approach. And if the approach light system is not operative, then you need 1,500 meters RVR.
Below 1000 feet AGL, go around and prepare for another approach reconfigured to lock, glide slope out, or another type of approach. No real need to consider a diversion as the problem is coming from your equipment. Of course, if ILS is the only approach available, you have to divert to another airport where you can use a different approach type.
Failure of the lock receiver.
You have no more indications on your PFD about your ILS lateral profile positioning, localizer, ILS, LOC is no longer flyable. Above 1000 feet AGL, you can reconfigure to another type of approach, reset your minimas, brief the approach differences and the descent profile. If you completed all your tasks before 1000 feet AGL, then you can continue the new approach. If not, go around.
Do not forget that, now, you need new RVR minimas and ceiling, for 2D, to be authorized to start the approach.
Below 1000 feet AGL, go around and prepare for another type of approach. No real need to consider a diversion as the problem is coming from your equipment. Of course, if ILS is the only approach available, you have to divert to another airport where you can use a different approach type.
Failure of the screen, AFIS.
On the G1000, you have an automatic changeover feature that switches your MFD to a PFD and you recover all your informations to be able to shoot your ILS. You will still have a GPS map available through the inset feature.
Keep in mind at all times. Error. unable to hold the localizer.
At 1 mile from the runway, being 1 dot off on the localizer means you are 100 feet off the center line. A dot and a half means you are 150 feet off the center line, that's 4 wingspans. Many corporate flight departments and airlines call for a missed approach with just a 1 dot deflection. Chasing the needle is guaranteed to fail.
Fixes.
When the localizer needle moves, you move, make small changes. React to the needle tendencies, not movements. Not more than 5 degrees correction in heading, 2 degrees correction in pitch at one time, and give some time to the needle to react. Find a heading that holds the needle centered.
Error, unable to hold the glide slope. Fixes.
You failed to get pitch stabilized on the approach. Use a predetermined power setting to pitch to a specific airspeed. Use trim to set your descent rate, about 500 feet per minute at 90 knots ground speed. Make small pitch adjustments, not more than 2 degrees at one time. Give time to the needle to react. React to needle tendencies, not movements.
Error, arriving at the outer marker, the final approach fix, unprepared. Fixes.
Use next step concept to be set for the approach well before reaching the final approach fix. At the final approach fix, intercepting the glide slope, use the 5 Gs concept. Gear, down. Glide, follow. Go timer, if needed for approach. Go around, altitude set on altitude bug. Green lights, gear and flaps lights checked. Fly the approach as if you are going to miss. Review the first steps of the missed approach.
Error, failure to make use of all the radios available.
For example, use the second VOR as a localizer backup, if you don't need it for anything else. Use the NDB to identify the outer marker fix if there is one.
Fixes.
Review the approach plate for all immediately useful radio aids. A common mistake is to forget the outer marker audio button or locator outer marker on an ILS.
The 5 most common errors on the ILS.
Failure to understand the localizer's course dimensions. Failure to intercept and capture the localizer outside the outer marker. Failure to establish stabilized power settings and trim for airspeed. Failure to maintain awareness of where you are before, during and after the approach if you miss. Failure to understand the approach, to properly brief it to yourself.
If you can't explain what you are going to do, you can't fly it.